Hi folks! Today we're going to be looking at one of the most complicated engineering marvels out there, but also one of the most common, bridges. A bridge is something used to get from one point over to another one, usually over something like a river or a road or whatever. And this is the simplest type.
We call this a beam bridge because it's a straight beam connecting 2 points. Beam bridges are very common and fairly easy to build. They range from something as simple as a tree knocked down across a riverbank to something more engineered, like this one.
Now there's an obvious flaw in a beam bridge, which is that the middle is usually under quite a bit more tension than the edges, which means it can bend and even break, like this. Now the obvious way to sort that out is to make it stronger. And as you can see here, that's far less likely to bend and break. And then there's another way, which is to build a different type of bridge altogether.
This is an arch bridge, and this particular one was made by famous bridge engineer Thomas Telford. An arch bridge is similar to a beam, but has arch supports underneath each end, called an abutment. These support the centre of the bridge far better.
So, here we have our arch bridge, and I mean it's so much more supported in the middle, completely. But it can only be so long.
And the solution to that problem is to build more arches, like this bridge in Dumfries. Now, adding more arches makes it even more difficult to build this bridge, particularly in the pre-industrial era. I cannot imagine how difficult it was to get the bricks out there. What blows my mind is that this bridge, built 400 years ago, is still in use today. These bridges were built to last with very little maintenance, and because of that, there's so many arch bridges made of stone still around and still in use. Of course, this doesn't make them perfect. In fact, this bridge replaced one that was washed away by flooding, and you can see how the builders have attempted to reduce the water pressure on the pillars with these cutwaters.
Another problem with arch bridges is, even though it is far more supported in the middle, if I really put some pressure on it, like so, you can see the actual bank is starting to shift away, and that's a problem. And it's kind of a difficult one to solve until we gain access to much stronger materials with the beginning of the Industrial Revolution.
And where better to see these changes than the Forth bridges? Spanning 3 centuries, the Forth Rail Bridge, Road Bridge and Queensferry Crossing are emblematic of the evolution of modern bridge design. These bridges are designed to be efficient, taking the maximum load for the minimum expense, with a wee dash of aesthetic value thrown in, of course.
So this is our wee model of the Queensferry Bridge, which is a cable-stayed bridge. And the main difference between this and a suspension bridge like the Forth Road Bridge is that instead of having a main cable going across from which these cables are then suspended, they just go directly from the tower to the deck of the bridge. And you can see how much more support this gives it, because all of the tension, can really put quite a lot of pressure on here, is in the cables or the string in the model's case.
As you can see, these don't rest on the banks nearly so much as their central supports, and the bridge deck is held up by the scaffolding above. That might be a static scaffold like the Forth Rail Bridge, or it may be cables like the other two.
Well, there you have it. A wee overview of how bridge design has evolved over the years. Of course, there's lots of other types of bridges than the ones we've discussed here, too many to count. Feel free to have a go at making your own bridge, whether from connects like myself, or from whatever you can find around the house. And if you do, please do send us photos, we'd love to see them. You can find contact details in the description below the video. That's all for now. Bye bye!